You've probably stared at anatomy diagrams for hours trying to memorize them, and then you just forget everything a couple days later. And the reason for this is because you're fighting against the way your brain naturally works. The students who master anatomy aren't smarter or more disciplined. They just discovered that anatomy is not a set of facts that they need to memorize. It's a story about how your body works as one integrated system. And in the next few minutes, I'm going to show you 3 principles that is going to completely transform the way you approach studying anatomy, and it's going to allow everything to stick. I want you to imagine that you're trying to understand a city by memorizing every building without knowing which ones are houses or schools or hospitals, for example. See, and that's what most anatomy students are trying to do. They're trying to memorize facts about the liver or the spleen or muscles like biceps brachii without really understanding the context surrounding all of that anatomy. Now, the reason why that's doomed to fail is because neuroscience tells us that your brain stores information in hierarchies, not in random lists. So you can think of it like folders within folders on a computer. These are broad categories, but they have specific details inside of them. When you work within this natural architecture, memorization becomes extremely easy to the point where it's automatic. So I want to show you an example so you understand what I mean. Everything starts at the cellular level. This is your basic unit of life, and those cells will then organize themselves into tissues. So this is like muscle tissue, nervous tissue, epithelial tissue, and connective tissue. And these tissues then combine to form organs, so like your heart or your liver. Then organs work together in systems like the cardiovascular, digestive, nervous systems. And all those systems integrate to form you, a fully functioning organism. The reason this hierarchy matters is because everything you're going to be learning in anatomy is part of this framework. So if we just look at biceps brachii, for example, most students are going to begin their studies by memorizing the fact that biceps brachii originates at the supraglenoid tubercle and coracoid process of the scapula. And I'm not going to sit here and pretend like that information isn't important, because it is. It's just, if that's where you're starting, this is going to be pretty hard. Instead, what you want to do is provide the context for biceps brachii, right? It's a muscle, so muscles are going to enable movement. The nervous system is going to be ensuring that muscle can contract in the first place. The cardiovascular system is going to be providing blood supply. And then the muscle itself is going to be part of thermoregulation because it produces heat. And I know that seems like we're just adding more information, but we're really not. This is the big takeaway I want you to understand. When you study this way, you're actually memorizing less information, not more. Instead of storing thousands of disconnected facts, you're building a connected framework where everything relates to everything else. Your brain chunks related concepts together because that reduces the overall cognitive load. So instead of thinking like scapula and humerus, we would really want to think about it first as the shoulder joint or shoulder region. And that's because now we have this one thing, right? You want to start broad and then start zooming in and looking at the details. So you start broad shoulder, and then it's like, okay, what system does this belong to? Oh, this is going to be the skeletal system. Okay, what are the bones? What are the tissues? What are the cells doing, right? When you start broad and then zoom in, everything is just going to have more and more perspective, and it gets easier and easier for your brain to handle. This is exactly how Kenhub organizes content. There's system overviews before the individual structures. Because when you understand the big picture first, you have a good sense as to where things are going and why these pieces are going to be important. Everything just starts to fall into place and make sense. But anatomy isn't just about what things are. It's about where they are in relation to each other. You could memorize every single street name in a city, but if you do not know where they are, how they connect, I mean, you've really done nothing at all except memorize a list, right? Things exist in a relationship with each other. So if we went back to the scapula and the humerus, like we were saying, right? Yes, there's a scapula and a humerus, but in reality, it's like together they form a relationship. Muscles are not just floating freely on the body, right? Nerves aren't just randomly going places, right? Things belong in a spot for a reason, and it's a really good idea to understand that relationship. This is because your brain is exceptionally good at remembering relationships. That's because it has relational memory, where your brain encodes not just objects, but the connections between them. Studies show that when you learn items as a network of relationships, recall is dramatically stronger than if you just learned them as a list. It's why you remember the plot of a movie, but you forget a shopping list. Movies have narrative. This is a story that has cause and effect. Things happen for a reason. A shopping list is just items, right? It's just things assembled together. And that's not going to be overly useful, which is why we need to find a way to have anatomy not be a shopping list and instead be a story, something that has a narrative and relationships that your mind can work with. So the first question you want to ask yourself is, what is it near? So if we look at the pancreas, for example, the pancreas, which is going to produce insulin and glucagon, you could learn about the head, the tail, the body, all that stuff, right? That's all valuable and important stuff. But if you do not know where it is, then this is going to be even more challenging, because then all of a sudden it's this abstract thing that just kind of exists. If in first you learn, oh, it's around L1, L2, it's retroperitoneal, meaning it's behind that connective tissue divider. It's behind or posterior to the stomach, right? When you start seeing where it exists in relation to other things, all of a sudden it's almost like it becomes a person. It's like it's become this thing that you're like, oh, it's the pancreas. It's pancreas, instead of just being like the pancreas. The next question you want to ask yourself is, what passes through it? So if we were to look at this giant hole here, which is called the foramen magnum, which literally means big hole, you want to ask yourself, okay, well, what travels through it? Because there are a lot of holes, right? There are a lot of foramini in the skeletal system, and that's because this is where blood vessels and nerves are going to be traveling through. And I cannot tell you how many times I have asked a student about the hole at the base of the occiput, and they'll just quickly say, oh yeah, that's the foramen magnum. And I go, what's it for? What's going on there? And they just are blank, right? They immediately know like where it is, but they don't know what it's for, right? This hole exists so the spinal cord can exit from the brain, right? The brain transitions, the brain stem transitions into the spinal cord, and then it's going to go down the vertebral canal, right? We want to make sure that we're understanding what is going through and around and in, like all of this thing, like what is happening with this structure. And then the last question again is, what does it connect to? I mean, going back to, we had the scapula, we had the humerus, but this goes with other things. What does the neck connect to? And that sounds obvious, but another way of saying it, what do the cervical vertebrae connect to? They connect to the occiput, they connect to the thoracic vertebrae. What do the ribs connect to? Oh, the ribs are going to connect to the vertebrae. They're going to connect to the costal cartilages. When we start going through the list here, sometimes it's going to be obvious, sometimes it's not going to be as obvious, but the point is not about whether or not it's easy to put these pieces together. It's more about building that mental framework and orienting yourself to just understand that this is a system. So it really is that game, like the knee bones connected to the song. You're just basically trying to create this mental 3D map in your head that you can always rely on, right? And so for me, whenever I'm picturing the humerus, I don't just picture like this floating humerus in my head. That would be crazy. Instead, I am picturing the humerus as it relates to all the other bones in its area. But there's one more principle that I want you to understand, because this is what transforms memorization into true understanding, and I can promise you this is what makes everything click. Anatomy tells you what something is. Physiology tells you how it works. There's a reason why you're going to see so many programs are anatomy and physiology. That's because they go hand in hand. I love anatomy. It is absolutely amazing, but it can also be incredibly boring and tedious. I mean, it's really a science of classification. So I'm always telling my students, even if I'm only there to really teach them anatomy, that we should also be learning some physiology along with it. And at first, their response is always the same. I don't want more to learn. And that's not the point here, right? This is about understanding. This is not necessarily about just adding more meaningless information, right? We want to build this. And so you got to start asking yourself, what is the function of this? How is it like this? This is more of like that why and everything that gets built into it, because again, the anatomy is what. So for example, if we were to look at, say, the heart valves, right? So we have like tricuspid, bicuspid, aortic, and pulmonary valve. So at first you learn these and you're like, okay, well, what do? They prevent backflow. Well, that's nice. That's good. That's something, right? That's some physiology right there. You're giving a function to it. But then the question might be like, okay, but why are they shaped the way they are? Why is one a little bit thinner and more flexible than the other, right? Because if you looked at the tricuspid and bicuspid valves, they're shaped more like parachutes, right? They have these little papillary muscles, these little heartstrings called the chordae tendineae, and then, the actual aortic and pulmonary valves. These are just flaps, right? They just kind of, they get sprayed open and then they kind of snap back. And the question is, well, why on earth do they need to be shaped differently? And then you start to look into it and you're like, well, it has to do with how they actually engage with the pressure from the ventricles contracting, right? The flaps need to just quickly be blown open, right? We're talking like the aortic and pulmonary valve, and then hurry and collapse back and close. And that's essential to be able to move like that. Whereas the tricuspid and bicuspid valves, they're more like parachutes because they need to have flexibility because they're resisting pressure this way, and then and it's shifting the blood out towards the pulmonary and aortic valves. And so my point is more so when you start asking yourself, why is this the way it is? How is it working? And you start piecing this with the anatomy, all of this sudden everything just starts to come into focus, and it becomes so much easier to understand the anatomy because you understand why it's like that in the first place. This works because of what's called elaborative encoding. It's a process where your brain links new information to existing knowledge through meaning and context. When you memorize just like some fact, like inferior angle, superior angle, acromion process, right? That's just arbitrary information. The chances of your brain holding on to that are slim to none. But if instead it's like, okay, superior angle, this is where levator scapulae is going to attach, and then when it's going to pull it, oh, that's how it's going to elevate the scapula, acromion process. Oh, this is where the clavicle, the acromial and the acromial when you start putting it together, all of a sudden it's like it's a puzzle. The things just start to fit. And now you see the picture, it's so much easier to process. When students learn anatomy and physiology together, they don't just memorize better, they understand deeper. They see the body not as like a catalog of parts, but as an integrated functional system where every structure has a purpose. Every time you learn a new structure, I want you to immediately ask, what does this do? Now, chances are you're probably going to be getting that in your notes or in your textbook as is, but a lot of times students just take it for granted. Instead, they're just focused more on its physical location, which again is important. It's just more so we want to know, like, okay, if it's a muscle, what is it doing? If it's an artery, where is it delivering blood, right? If it's a valve, what kind of backflow is it preventing, right? You want to immediately ask, what is it doing? And try to connect that with something else you've already learned, or maybe you can just better intuit so that it all starts to make sense. I will preach this to the end of my days, that function is the glue that holds everything together. If you want to dive deeper, go ahead and check out the free Kenhub article in the description below. It's all about more strategies on learning anatomy holistically. And while you're down there, go ahead and leave a like, comment, subscribe if you're feeling pretty fancy. But I appreciate you hanging out with me like you did, and I will see you in the next video.